hopefully, I know it's hard to think of this as like a unit circle, but also just a list of angles. But the pi over 6, 0.5, 0.866. Pi over 4 is, 707. And both of those are the same because of pi over 4, the x and the y value for cosine and sine is the square root of 2 over 2, square root of 2 over 2. It's really what you're finding here. You're finding the ordered pair on the circle. It's just as a decimal. And then pi over 3 should be pretty much the opposite of pi over 6 because on the unit circle, those guys are flipped as well. So this is 0.866 and then 0.5. And then in 90 degrees, we have a 1 and a 0. So you shouldn't have any other values besides those. The only difference would be you would have a positive or a negative depending where the angle is located. So the next one for pi over 3, I should take my same two values for pi over 3. At 2 pi over 3. Except what changes with that ordered pair? And
1/2 is negative.
Yeah. Because cosine is negative and that angle is in the second quadrant. So if the angle's in the second quadrant, cosine's negative in the second quadrant. 3 pi over 4, again, looking up the pi over 4 value. And then that should be negative. 5 pi over 6. And then that should be negative. And then, of course, this is a 0 and a negative 1. Like, same numbers. It's just the cosine is negative because the angle's in the second quadrant. Cosine is negative in the second quadrant. So then the third quadrant, again, same numbers, except, Hannah, in the third quadrant,
Both
both are
are negative.
negative, yeah. So both negative in the third quadrant. And then the last one, Hannah, when you're in the fourth quadrant,
Y is negative.
excellent. So our sign should be negative. And the cosine is positive. And then you're back at the full circle when we get the 2 pi. So that's kind of just remembering about the location of the angle and the property of the angles. The denominator is a family of angles. So they have the same value if it has a denominator of 4, or 3, or a 6. Just kind of translating those numbers down to a different area. So when you open your packet up like a book, on the other side of the chart, so flip to the next page, open it up, you'll see on the other side of a chart, it gives you some directions, which I'm going to go over with you. And then underneath that set of directions are questions. These questions, you're going to look at a graph and answer for cosine or sine and cosine as much of the information that you can get from the graph. So the questions down below, after you have a graph, you'll be answering them. That worksheet there is due on Wednesday. So the answer is looking at those questions and kind of answering those for the sine and the cosine. If you look next to it, there is beautiful graph paper, huge, 2 graphs. One for sine, one for cosine. I made it large, spread it out because we're going to get a nice, neat picture. And I'd like you to tear that page out so that you don't have to flip back and forth. And then you can take your packet and go back to the chart page that you just filled out because we're going to use that chart and we're going to plot points from that chart. So if you just flip back to the page you just filled out with all the decimal values and then just have your graph paper. And Scott, I sent you part of mine, but I can send you the completed version then. So you don't have to plot all the points. So the first thing that we're going to do is we're going to label the graph. So if you look at your graph paper and the chart, all of those 16 angles that are in your chart represent our x-axis. So the x-axis is now our angle values. So no longer is it x, but it represents all of the angles. So we're going to take that huge list that's going down vertically, and And we're gonna actually expand them and write them horizontally. So we have angle 0, and then I'm gonna go over 3 spaces and label that with pi over 2, because pi over 2 is our big quadrant angle. It divides the quadrants in half. So we consider pi over 2 to be a pretty important angle. It's at the top of the unit circle. I'm going to go over 3 more spaces and call that pi, because again, that's our next quadrant angle. It's halfway around the circle. It's a pretty important angle to be halfway around the circle. Again, go over 3 more. Call that 3 pi over 2, and then at the end, that would be 2 pi. So the first thing we did is just broke it up into fourths, which is why you have 12 little tick marks there, so we can break it up into fourths. The next thing we're going to do is we're going to go back into that each quadrant, and we're going to write the 3 angles that are in the middle of the quadrants. Those are our special right angles. So going back to the starting point, in the middle of 0 and pi over 2, directly in the middle. What angle is directly in the middle of 0 and pi over 2? What angle is in the middle of 0 and 90 degrees? 45 degrees. So in the middle of 0 and pi over 2 is our 45-degree angle, or pi over 4. So that goes in the middle. And then 15 degrees either direction is pi over 6 or pi over 3. So the first angle on that actual line is pi over 6. And then the other line gets the angle of pi over 3. So you have 3 little angles that are really close together because they're only 15 degrees apart from each other. So each line increment is actually 30 degrees. And then I have one in the middle because we have that 45-degree angle. So I'm going to continue to label it going down vertically. So following your angle, after pi over 2, the next angle on your chart after pi over 2 is 2 pi over 3. So that's going to be then my next angle, 2 pi over 3. And then I would have my middle angle of 3 pi over 4. And then 5 pi over 6. Mine are looking close together and sloppy because my point only goes so small. So see if you can continue to write the next group of 3 angles. So you're trying to label horizontally the x-axis based off of your chart, the vertical angles. And I'm labeling at the bottom so that the angles and then like numbering doesn't get messed up within the points that we plot. It just looks neater to have them at the bottom so we can see our points a little clearer. So again, I'm just working my way down that chart as I'm labeling the middle 3 angles. And yours look a lot neater than mine. I want you to do the negative quadrant angles on the negative side. So if I go over 3 places, I'm going to call that negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi, so that I have the left and the right angles labeled. You do not have to label all of the angles on the negative side. I'm just going to put little tick marks in the middle. So I'm going to put my little tick marks, but don't label them. That would be like unnecessary labeling. Just place the little tick marks. So again, the reason those 3 angles are so close to each other is because it goes 30, 45, and then 60. And those 3 angles are just 15 degrees apart from each other. every box on this graph represents a 30-degree angle. My 45 is in the middle of 30 and 60. So that's why you have those three little points that are going to be close to each other. So the last thing we're going to do is we're going to graph points. So on your chart, we're only doing sine right now. So the sine value, my angle is x, the value for sine is y. So it creates an ordered pair of 0, 0. When I go to graph cosine, it creates an ordered pair of 0, 1. So now, whatever answer you get from the calculator, that's your y value. The angle is always x. You don't have to go through and write all the ordered pairs, but that's really what we're going to do. So we're going to plot points. So this would be pi over 6 and 0.5. Or this would be pi over 6 and 0.866. But we're going to graph these points now. So we're going to take all of these values. We're going to see what this graph looks like by plotting these 16 points. So now I have an ordered pair of my angle and the value for sine, and we're only graphing sine right now. So going on your graph paper, there we go. At 0, the value for sine is 0, so I put a little point there. Julian, at pi over 6, the value of sine is 0.5. So since it's 0.5, why don't we go up 4 and call that 1? Go up 4 more, we'll call that 2. Just again, kind of spreading it apart so these things aren't squished together. So if I go up to 0.5, I should then go halfway up. And then we can go down 4 more. Julian, at pi over 4, what's the value of sine?
0.7 is 7 over 7.
Yeah, so which is a little less than 3/4 of the way. So I'll go a little less than my third line. And then Julian, one more time, pi over 3 is?
0.866.
So at my pi over 3 tick mark, 0.866 is going to be somewhere in between the third and the fourth line. And then at pi over 2, I have a point of 1. And now I have the angles graph for the first quadrant. And you can see how it kind of makes like a little curve. So after we go through some questions from the review, if you want to, you can work on continuing these graphs or you can continue to review. It's up to you. But if you can just put that aside for a minute. So your goal is to finish graphing both sides. So you're going to graph the right side and then you're going to graph the left side using what you know about sine. And then you'll do the same thing for cosine. You'll graph, label the axis, and then you'll graph it. And then after you have this graph, you're just answering a couple of questions about things you know, like domain and range, max and min. Like the questions that you know about graphs, just trying to analyze these trig functions with the same questions we would use to analyze algebra. Questions? No, we won't be plotting 16 points every time we graph. We'll plot 5. Not 16, but you kind of need to have all 16 to see how the graph is created. So, looking at the review worksheet that you had from Thursday and Friday. So Thursday's review worksheet was the first one in your packet. Friday's was the second one in the packet. What questions would you like to go over from either of those two worksheets from pages 35 to 39? Julian.
Can we go over number 3 on the second?
Number 3 you said?
Yeah.
Yep. So number 3 on the second page says the cosine, and then you have a little 0 with a line through it. That's the same thing as theta. That's a phi instead of a theta. Any angle, anything that's after the cosine, that just represents an angle. So it's like having an x and a y and a z. So we have the cosine of this angle is equal to 0.3, and it says to find the sine. Usually when you're given the cosine, it's not equal to a decimal. Generally, it's equal to what kind of number? Julia?
Fraction.
A fraction. Because cosine is what two sides of a triangle, Julia? Adjacent and hypotenuse, or it's x over r. So instead of looking at this as the cosine being 0.3, again, it doesn't matter what you use there. If you like having the theta, place the theta there. Julia, how could we write 0.3 as a fraction? 3 over 10. any decimal can be written as a fraction. Actually, I shouldn't say any. Most decimals can be written as fractions unless it's an irrational value. But 0.3 is 3 over 10. So now we have the cosine of some angle is 3 over 10. Julia said it's the adjacent and the hypotenuse. When in doubt, make yourself a triangle. If you don't know how to solve the problem, either draw a circle or make yourself a triangle. Because it's going to be related to one of those two things, either the unit circle or a triangle. And label the sides. So the adjacent, I'll call my angle right here. This orientation must be off. Whenever I draw my line, it just doesn't go where I want it. There we go. So adjacent is 3, hypotenuse is 10. Julia, how can I find the vertical side? Yeah. So 3 squared, I'll call it y squared, 10 squared. So Julia, 100 minus 9 is 91. Yeah. So this is the square root of 91.
Would it be harder if you use the trig identities?
Not at all. You can use the trig identities. That's totally up to you. I just think probably most people don't feel comfortable using the trig identities. And saying that, there was a question for my first period class. You will not be assessed on any of the trig identities, like applying them. You have to have them memorized. But you wouldn't have to apply any of the trig identities or simplify any of those. So I wouldn't give you like the sine times the tangent equals the cosine. Show how that works. So you won't have any problems or be asked to like simplify or use the trig identities. You just have to know what they are. That was a question that somebody asked during my first class. You would get the same exact answer using trig identities. Sine squared plus cosine squared equals 1. But sometimes just drawing a triangle is easier. Another question from the review. Ashley.
15 on 36 for page 36.
That's just the previous page. So we did 16 together. So if we look at 15. So 15 says find two values of theta from 0 to 2 pi that satisfy the cotangent being -1, which we also know if the cotangent is -1, the tangent is -1. So Ashley, before we do anything with the calculator or from memory, where would those two values be? What two quadrants would our two values be in? If we have tangent being negative.
In the second.
And the fourth. So two values, two answers in angle form. That's what we're trying to find. Theta is an angle. So we want two answers for theta. One in the second quadrant, the other one in the fourth quadrant. This says that you can round to 3 decimal places. However, you could get this as an exact answer as well if you prefer to have it as an exact answer. When on the unit circle would the cosine be equal to -1? Why would a number be equal to -1? Think of the ordered pairs that we just went through. Asher?
The x and y are the same except for negative.
Yeah, so I would get an answer of -1 or +1 if the x and y are the same. So this is from the unit circle. Thinking the only way I can get a -1 is if x and y are the same. And they're the same at this ordered pair, which is the same ordered pair that we had just on that little sheet that we did. Any angle that had that same value would give me a tangent that's the same. So in the second quadrant, I would have a -x. And in the fourth quadrant, we would have a -y. So let's go back to this ordered pair, Ashley. What angle would have a value for the square root of 2 over 2 square root of 2 over 2? 45 degrees. Or as a radian value, since it says 0 to 2 pi, that would be pi over 4. So my angle that I need to think about is pi over 4. That's your reference angle. So I need to have an angle that's less than pi by pi over 4 and less than 2 pi by pi over 4, because that pi over 4 is your reference angle. So what angle would be less than pi? Do you know, Ashley? So if I have pi and I have to subtract pi over 4, say it again. 135 or 3 pi over 4. So 3 pi over 4 would be one angle answer. 3 pi over 4 is in the second quadrant, and it has the ordered pair negative square root of 2 over 2, positive square root of 2 over 2. And then if I do the same thing with 2 pi, it has to be less than 2 pi to be in the fourth quadrant. So take 2 pi minus pi over 4. And you can get a common denominator if you need to. That would be a 4, so this would turn into an 8. So Julia, 8 pi over 4 minus pi over 4 is
7 pi over 4.
7 pi over 4. I did that without a calculator because I know you'll be asked to do it without a calculator if it's an angle on the unit circle. You plug it in the calculator by using second tangent. You're going to get the same answer except that angle is as a decimal instead of as a nice exact value. Julie, any question? No. Scott, you had your hand up. Oh, perfect. Yes. Other questions, Julia?
Are there gonna be the ones where you have to do it from like degree, minute, and seconds into
Where you have to multiply by 60? Yes. So whatever that decimal value is, take the first, the big answer, that's your degrees, multiply the rest of it, the decimal, remaining decimal by 60. Take the remaining decimal, multiply by 60. Yes, you could have that. Julian?
Will we have the ones where we have like an equal sign and then two things on each side and then we have to like prove?
No, you won't have any of this. So no. No proving or verifying. Because all of chapter 5 is that. We just looked at it briefly. It wouldn't be fair to test you on it. That's after the midterm. So like the end of January, beginning of February. Hannah.
Since you said we didn't need trig identities, but we have to memorize them, is there like matching like our little quizzes, or like not matching, but like
But just like basic facts.
yeah.
Yeah.
Okay.
So basic facts. Other questions? Julian.
So like moving out.
It's
So on the last one on the second page, I had to look up how many feet were in a mile. Do we need to know that?
Oh, to 5,280?
Yeah, I didn't know that.
You didn't know that?
No,
But now you do.
I won't remember it.
Oh.
Do we need to know that?
5,280. I'll give you a conversion if you need to know a conversion.
Okay, because I had to like Google that, and I was like, yeah, I don't know how much is that.
if you take physics, you'll know.
Yeah.
I'm gonna do physics.
Next year you might.
Don't take physics.
Don't listen to her. Next year you might. And they're like 2.24 centimeters in an inch. Like it's just those crazy
Oh, I don't
things.
know.
I just don't know that. I don't know how much.
We're never gonna need to know that.
You're never gonna need to know that. Other questions that you have? Yeah.
How do you know the difference, like, from whenever you have to find the 6 trig functions? How do you know the difference whenever you need to use the radian or if it's just over 1, or the radius? If that makes sense.
Oh, yes. If you're given, I know exactly what you're talking about. So, if you're given a number like 7/13 or 7/8, or if you're given a value like 1/2. Is 1/2 on the unit circle as a value anywhere on the unit circle? Yes. Is 7/13 anywhere on the unit circle? No.
So if it's not on the unit circle, you need the radius.
Correct.
Okay.
If it's not a number on the unit circle, you need the radius. So 1/2 square root of 2 over 2, square root of 3 over 2. Those are the 3 numbers from the unit circle.
Okay.
Anything other than that is not on the unit circle, and then you'd need the radius.
Okay. Thank you.
Other questions? These are good questions. Julia?
What are some of the keywords to where to put the, like the angle where you're finding like the angle on like word problems? Because sometimes I'm confused
Oh,
on where I should put
yeah.
the angle.
Oh, goodness. Oh no. So if it says angle of elevation, it's always the bottom angle where the person could be standing looking up at the object. So the angle of elevation is always from the point of view of whoever is observing the object. This one right here, like you're making an angle with the wall, and the ladder has to be propped up against the wall. So like think about where is your wall, what angle is connected to the wall. So it's making an angle with the wall, or with the, I think we did one with the river, like it has to touch the river, connect with the river. But the angle of elevation, which is the next one here, like elevation is always the angle at the bottom of the triangle. Whether you draw it like this or whether you draw it like this, but my object is up here, somebody is looking down below up at the object. So it's always the bottom angle where you would elevate your head to view that object in the sky. Ashley. So if it specifically says it's connecting with something, make sure it's connecting to that value. Like here it says with the ground. So where is the ground? The angle has to connect to the ground. Other questions? So I'm going to leave you with the next 7-ish, 6-ish minutes. There is on the assignment sheet from today, there is an assignment in the book that if some of you want more problems to review, you can look at those problems. It's not an assignment. It's optional. So in the book, I think it's on page, I honestly don't remember, it might be 4 something. But there are problems in the book, because people always ask me what other problems can I do. That you can do the odds and you can then use the answers in the back of the book if you choose to do so. You have 5 separate review worksheets. You have a review worksheet for 4-1, 4-1 to 4-2, 4-1 to 4-3, and 2 for 4-1 to 4-4. And then you have a ton of little quizzes. So you have a lot of stuff to look at and use to review and prepare for the test tomorrow. Next Friday, you will have another test. It's going to contain the graphing and all of this. So it'll be a 4-1 to 4-5 test. And yes, I'm the teacher giving you a test on Friday before break. The other option would be to take it the day before, like when you get back, which pretty sure nobody wants to do that. If you aren't going to be here next Friday, you can feel free to take it anytime on Thursday, because we'll be reviewing Wednesday and Thursday. Thursday's just an extra review day next week. The what? Make-A-Wish field trip is next Friday, so take it on Thursday. You can choose to take it in class, you can choose to take it after school. Questions? So you can work on the graphs, seeing if you can get some more points plotted in the next 5 or so minutes. You can continue to review. Please ask questions.